So to shift into third gear, we had to do what to the solenoids?
De-energize all of them.
Yeah, well, one was already energized, de-energized. So we just had to de-energize the 2-3. When we de-energize the 2-3 shift solenoid, a couple of things going on here that I want to make you aware of. One is, first of all, the 2-3 signal fluid pressure exhausted. That little orifice keeps our AFL fluid from dropping, our AFL fluid pressure from dropping. That allowed what pressure to push our 2-3 shift valve over? What pressure pushed our 2-3 shift valve into the upshifted position? Yeah, AFL fluid. Remember, that was there in first gear, but it didn't do anything to the valve because we still had 2-3 signal fluid pressure here. But once we drop that, AFL fluid pushes our 2-3 shift valve over and our 2-3 shuttle valve over into the upshifted position. That allowed our AFL fluid to flow past the 2-3 shuttle valve into what passage?
D4.
D432, right? And that fluid went up to
1-2 shift valve.
where it's doing what?
Waiting.
Yeah, good. The valve is already in the upshifted position, the 1-2 shift valve. So that fluid, the D432 fluid, just went up there to help assist the spring pressure. I wonder why. You're going to find out in a minute.
The next shift.
Yes, that's why. And you'll see why in a minute. So our second fluid, remember we got that from D4, from the 1-2 shift valve. If this shift valve got downshifted into the downshifted position, would D4 feed into second? The answer is no, it wouldn't. So would we have second fluid to feed into our 3-4 signal fluid passage? No, we wouldn't. So we need that 1-2 shift valve to stay in the upshifted position. So second feeds into the 3-4 signal fluid passage. Let's bring it over to apply our 3-4 clutches first. So let's find our way over to there. And this is kind of confusing because it goes in a lot of different directions. But where it's going is down through here, right past this passage here. So it went past the number 13 orifice, it went past that. The check ball is unseated. Everyone see that? It's unseated?
Yes.
Yes? So we're not using the check ball on clutch apply. We're actually going to use this when we release the clutch. So right now we're going to bypass the orifice and it goes into the 3-4 clutch passage now, where it's going to go up to apply our 3-4 clutches. All the way up here in between those two Teflon seals. That's that apply hole, the furthest one down in the turbine shaft, and then up here to pressurize this area behind the clutch to push the clutch piston to the apply position, which is also going to push on the apply ring to push our apply plate. Now notice that our multiple disc clutches, they're all going to consist of an apply plate.
Is that the thick one on the back side?
Yeah.
Top side?
Yep. So that's the apply plate for 3-4 clutches. This is the backing plate for the 3-4 clutches. This is the backing plate for the forward clutches. There's the apply plate for the forward clutches. And for the overrun clutches, they're using the steel as the apply plate. So there isn't a separate apply plate for the overrun clutches. So on any of our clutches, you're going to find that there's going to be one plate that's going to be considered the apply plate. We got to push all those clutches up against another plate. That's the backing plate. And we're going to have some type of return spring to return the springs to return the piston to the release position. So we're also pushing against these springs and some kind of retaining ring so that we can, when we release the pressure, the springs push our piston back to the release position and the clutches are released. The backing plate on the 3-4 clutches and the forward clutches is selectable. That's the one where you do the measurement that you guys did, and if it's not right, you order another backing plate. On some of our transmissions, the snap ring is selectable. So the snap ring come in different thicknesses.
Well, in like the one that we did, there are different thicknesses for them. Those aren't selectable, right? They have to be that width, right?
Are you talking about the snap rings?
Yeah.
Right, yes.
Okay.
If you replaced the snap ring and it had a different width, then that's gonna throw your clearance off because your backing plate is pushing up against the snap ring.
Okay.
So you would have to make adjustments for that if you use a different snap ring, which I don't recommend. You want to use the original snap ring. Any questions on the 3/4 clutch apply? Are we okay with that? 3/4 clutches, notice that that same fluid that we're using to apply the 3/4 clutches also goes down unseating number 2 check ball. So again, it's bypassing that number 12 orifice and it's going over to our third accumulator passage. It's seating that number 7 check ball. You guys remember that one? That's the one that was in the case and that captured, that's that captured check ball in that capsule. That's the one you squirted fluid into the passage to see if it leaked. So it's going to be seating by this hydraulic pressure. So here's what I want to suggest to you. If your check ball leaked when you did that test, do it again by applying just a little bit of pressure to that check ball. You know, get a punch or something and just push down on it a little bit. You know, we got about 40 pounds per square inch or more pushing on this check ball normally. So if it leaked and you apply a little bit of pressure to it and it stops leaking, it's okay. If it still leaks when you apply a little pressure to it, then it's not okay. I hope that's clear.
Yeah.
Otherwise, you're just going to be replacing a bunch of number 7 check balls that really isn't necessary. Third accumulator fluid goes over to this 2/4 servo where it does what? Yeah, it's pressurizing that side of that piston. What's it doing to that servo tip? What's it doing to the band? Yeah, it's releasing the band, isn't it? We don't want the band to stay applied when we shift into third, because then we'd go into fourth. So we need to release it at the same time that we're applying the 3/4 clutches, which makes this what type of shift? A clutch to clutch synchronous shift, meaning the apply and release of these 2 apply devices has to be synchronized. So the timing is just right. So we're using some of that third fluid to go into the third accumulator passage to push our band into the release position. Third accumulator fluid also comes over to the control valve where it's blocked off. 3/4 clutch fluid went over to the control valve where it's just blocked off. We're getting ready to use those circuits for our 3/2 downshift. Our 3/2 downshift. Again, which is going to be, the timing will be critical because it's a clutch-to-clutch shift.